I'm Khadar Chuktagi and today I'm going to explain nomenclature of arenes. Nomenclature means how to give the name of a compound or how to report a name of an organic compound. Let's talk about arenes. Compounds having benzene ring are generally known as arenes. For example, here are these four compounds and collectively generally they are all said to be arene. In arenes, there are basically two portions. One is said to be the benzene ring, and this is the simplest arene. In this case, one is the other group. This is the benzene ring. This is other than benzene ring. Nh2 group is on the benzene ring. Here, benzene ring. This is a Cl group. Any halo group can be on the benzene ring. Methyl group with benzene ring. OH group and benzene ring. These group Nh2, Cl, CH3, OH, these all group are said to be substituents. There may be one or more than one substituent on the benzene ring. Basically, these groups are introduced on the benzene ring after substitution of one hydrogen atom. So one hydrogen of the benzene ring is replaced by these Nh2 group, Cl, methyl group, OH group. So these groups are introduced after substitution of the hydrogen present on the benzene ring. Let's talk about nomenclature of arenes. There are two main basic points for the nomenclature of arenes. Number one, if only one substituent on the benzene ring, that is monosubstituent in this case, there is a simplest way to write the name. First of all, we are going to write the name of substituents like NO2 nitro, if CH3 is there, methyl, if Cl or any halo group is there, it is said to be chloro, bromo, iodo, and so on. And then we write the complete name benzene. In case of one substituent, especially nitro, methyl or any alkyl, any halide, that is said to be halo, chloro, bromo, iodo, and so on. And then we write the name benzene. The second one is, if there is only one substituent on the benzene ring, then some special names are also over here. You have to remember phenol, if the benzene ring is having OH group, and if Nh2 group is on the benzene ring, then its name will be phenylamine. So in case of one substituent, there is simplest way to write the name of the compound. Two simple compounds are special names. Two special names are there, phenol and phenylamine. And other one, nitro, methyl, chloro. If the simple substituent, normal substituents are there, then first we write the name of the substituents, then write the name of benzene. For example, in this case, here is the simple normal substituents, you can say. This is the nitro group and here is the benzene. So simple, in case of simple substituents, normal substituents, or you can say the minor functional group as well. These are said to be normal functional group. First we write the name of substituents, normal functional group, then we write the complete name benzene. Second one possibility is, if there are more than one substituents, then substituents are written before and after the benzene ring. Then some substituents like normal substituents, nitro, methyl, chloro, these are written before the name of benzene ring. And major functional group substituents, for example, carboxylic acid, aldehyde, amide, benzoyl chloride are the functional group. Those are written at the ending part of the name. Their name is used as suffix. And we write just benz. Substituents, then benz, not ene. After removing this E and E, we write the name of functional group. For example, if we have nitro group as a substituents, so nitro, benz, OIC acid, benzoic acid. Nitro, benzoic acid. Nitro, benz, aldehyde. This is an aldehyde. Nitro, benz, amide. Nitro, benz, oil chloride. So these are the common example you can see there. Sometimes benzene can behave as a substituent itself. In this case, we write its name phenyl. Phenyl means if hydrogen is removed from the benzene ring, one less hydrogen of the benzene ring is said to be phenyl. This is the benzene ring C6H6, C6H5. One less hydrogen benzene is named as phenyl. Benzene is equal to phenyl. Here are three examples. In all these three examples, this benzene is acting as a substituent. So its name is phenylamine. This normal name of NH2 molecule is amine. So its name is phenylamine. Here this is an ester. In this case, once again, this benzene ring is going to behave as a substituent. So it is phenyl ethanoate. Phenyl ethanoate. And this is the ketone. Again, in this case, this benzene ring is acting as a phenyl, as a substituent. So its name is phenyl acetone. You can also write phenylethanone. So in these three cases, especially, benzene is behaving as a phenyl, as a substituent. Substituent groups like nitro group, halo group, and alkyl group are the simple substituents, you can say. This I have already told you that in case of monosubstituents, only one group is present on the benzene ring, then it's a simple mechanism. Write the name of that substituent and then add the word benzene. For example, once again, this is the nitro, a simple substituent, and here is the benzene, nitrobenzene. In this case, here is chlorobenzene. You can say these are the simple names or normal names that you have to remember by default. And here is methyl N-alkyl benzene. So if nitro group is on the benzene ring, if halo group on the benzene ring, if any alkyl group is on the benzene ring, then there is the format to write their names. First we write the name of their substituents, then we write the name of benzene. Here are major functional groups. In this case, we write the benz, then we write the name of functional group. For example, its name is benzoic acid. Benzoic acid. Its name is benzoyl chloride. So its name is benzoyl chloride. Similarly, here is benz, this is the benz, and this is amide. So we can write as benzamide. If there is a major functional group, so its name will be written as a suffix. Benzoic acid, benzoyl chloride, benzene is not having its ene part, OIC acid, OYL chloride, amide. Benzoic acid, benzoyl chloride, benzamide. Now come towards the special groups. This OH group and NH2 group. OH group and NH2 group are called special substituents. When OH group is part of the benzene ring, then its name becomes phenol. OH plus benzene ring is equal to phenol, and this carbon will be said to be or marked as this carbon will be the number 1 carbon. As far as the numbering is concerned, then this carbon will always given number 1. In case of more than one substituents are indicated with numbers. Numbering may be either clockwise or anti-clockwise in such a way to get lowest sum of the branches. For example, here benzene is having two substituents, one is OH and other one is the methyl group. This OH group is a special group. Its name will be in coordination with the benzene, its name will be phenol. and this CH3 will be treated as a branch. Now it's time to mark the numbering. As you know, it's carbon number 1 due to spatial group. So I'm going to mark the numbering clockwise and anti-clockwise. If we move clockwise, then this is position number 2, is position number 3. This methyl group is present at 3 position. If we are moving anti-clockwise, then it's position number 2, it's position number 3, it's position number 4, and it's a 5. Then the lowest number is preferred. So in this case, its name is 3-methyl. 3 is the position of this group, 3-methyl, and the rest of the compound is said to be phenol, 3-methyl phenol. In this case, once again, benzene is having 2 functional groups or 2 normal substituents. One is OH and other one is chloro. Once again, this OH is a spatial functional group and its carbon will be carbon number 1. So how to write the name of this compound? Once again, I'm going to mark numbering clockwise and then anti-clockwise. If we move clockwise, this Cl is getting 2nd position. If I'm moving anti-clockwise from OH group, it's getting 2, 3, 4, 5, and 6th position. But the smallest number will be preferred. So its position is 2 and it is acting as a branch. In this case, its name will be 2-chloro, and the rest of the whole molecule is phenol, 2-chlorophenol. In third example, you can see that once again one OH group and there is another substituent, that is nitro group. Nh2 is written as nitro. Once again, this is the carbon number 1, and by clockwise you can see that you are going to give the lowest number to this Nh2 group. So its name is 3-nitrophenol. 3-nitrophenol. But if major functional group is present, with the OH group, then the major functional group will be at number 1. I mean, in this case, here is the major functional group, that is carboxylic acid, and this is OH group. In competition with OH versus this carboxylic acid is a major functional group, and the carbon that is having this carboxylic acid is said to be carbon number 1. So in this case, this group will be preferred. It's the position number 1. Now, according to clockwise and anti-clockwise numbering, you can say the lowest position for this OH is going to be 3. I mean, it's 2, it's 3, and so on. As there is the major functional group, so the benzene will be written as with the name of major functional group. So we will write benzoic acid. Now, in this case, this OH group will be treated as a branch. It will be treated as a branch. Whenever you are going to write the name of OH in the beginning of the name, so you will write hydroxy. It will be written as hydroxy. So as a prefix, OH is written as hydroxy. Its position is 3, so its name is 3-hydroxy benzoic acid. Collective name overall benz, and this is acid, benzoic acid. In this case, this OH group is behaving as a branch. Once again, if OH group is in the competition with any other major functional group, then it will act as a branch. Once again, the next one is Nh2 Spatial Group. If Nh2 group is present on the benzene ring, there are 2 possible names. One is said to be phenylamine. If Nh2 is the part of benzene ring, then its name will be phenylamine. Usually it is written as phenylamine, or its common name is aniline. Once again, if there are more than 1 substituents, then substituents are indicated with the numbers. Numbering may be either clockwise or anti-clockwise, but in such a way to get the lowest sum of the branches. Just have a look. Here, this is Nh2 group, that is a spatial group, so its numbering will be 1. And this is the methyl group, you can say. You can also write CH3 over here. So it is acting as a branch. Now, the lowest number for this branch will be 2 and 3. I mean, if you are going to mark the clockwise numbering, it will get the lowest position, lowest number. So its name will be 3-methyl aniline, or its name may be 3-methyl 3-methyl phenylamine. Phenylamine. The next example is, in this case, once again, NH2 group will get preference and its carbon is said to be or marked as carbon number 1. And this Cl is at 4th position. So this Cl is acting as a branch in this case. We are going to write its name 4-chloroaniline, or we can write as 4-chlorophenylamine. 4-chlorophenylamine. If both spatial groups are present on the benzene ring, once again, this is OH group, this one is NH2 group. OH group is a spatial as well as NH2 group is also a spatial group. So in this case, preference will goes to OH group. OH having more preference than as compared to NH2 group. So this carbon will be carbon number 1. This is carbon number 1, 2, 3, and 4. This NH2 is having 4th position. And now this NH2 group is acting as a branch. So its name will be written as a prefix. If we are going to write the name of NH2 as a prefix, its name will be written as amino. Amino, right? So we are going to write it over here, 4-aminophenol. 4-aminophenol. We put dash, we write this hyphen between numbers and alphabets. 4-aminophenol is the name of compound. I mean, once again, if there is a competition between two spatial group, as far as the A-level chemistry is concerned, you will give preference to the OH group and its carbon will be said to be carbon number 1. If there are more than 2 substituents, then what to do? Check spatial groups first of all. And you will have to give the number 1 to the spatial group. Once again, there are 2 spatial groups. One is NH2 group and other one is OH group. So as you have seen that this OH carbon having OH group will be carbon number 1. Then we will write the numbering in such a way so as to get the minimum number of the branches. Once again, I'm going anti-clockwise and 2, 3, 4. If we are going in anti-clockwise, then there are 2 branches. One is present at 3 position, other one is at 4 position, and sum is equal to 7. If we are moving clockwise mode, then it's 2 position, it's 3, it's 4, it's 5, and the sum of the branches, sum of the number is equal to 9. And you know, the lowest sum will be preferred. So this is incorrect numbering and this is the correct numbering. Now it's turn to write the name of whole compound. There are 2 branches. One is the methyl branch, other one is amino branch. It's amino branch, it's methyl branch. These 2 branches are these 2 substituents are written with respect to their alphabetic names. So its name will be, 4-amino, as A comes first in the alphabets, then dash, then 3-methyl, 4-amino, dash, 3- or hyphen methyl phenol is the name of this compound. 4-amino, 3-methyl phenol is the name of this compound. There are few more examples. Once again, if there are 2 or more than 2 functional groups are the substituents are over here. Here are 3 examples. Let's see over here. In this case, this is a carbon number 1 because it's having spatial group. It's carbon number 2, it's carbon number 3. It's acting as a branch, the Cl, and its name will be 3-chloro 3-chloro-phenylamine. In the second one, you can see that the both substituents are similar. Any one carbon can be marked as carbon number 1. So this is the carbon number 1, 2, 3, 4. So its name may be written as, can be written as, you can say 1, 4, because both branches, both substituents are similar. So their numbers will be written consecutively. And we use comma to bifurcate to separate the numbers. Then dash, there are 2 branches, we write di, and it's chloro, dichlorobenzene. 1,2-dichlorobenzene is the name of this compound. If the 3 groups are there, if the 3 substituents are there, in this case you can see that one is the spatial group, that is OH group, and other are the simple substituents. Its carbon will be the carbon number 1. Now I'm going to mark the branches, and if you are moving clockwise or if you are going to move anti-clockwise, in both way the numbering of CH3 and Br is going to be same. But in this case, the preference goes to alphabetically. So Br, that is starting from B for bromo, M for methyl, this Br will get lowest number. So numbering will be anti-clockwise. In this case, it's a carbon number 1, it's carbon number 2, it's carbon number 3, carbon number 4, 5, and 6. So the lowest number should be for bromo. So now it's turn to write the name. Its name will be 3-bromo, 3-bromo dash 5-methyl phenol. As you know, this OH group is written with the benzene ring. Major functional groups are supposed to be at one position and written as suffix, as you know. Major functional groups, in this case, this is the major functional group, this is the major functional group. So in this case, its carbon will be carbon number 1. Its position will be at 1 carbon. Its position will be also at 1 carbon. And in this case, this nitro group is acting as a branch. So its name will be 1, 2, 3, and 4. 4-nitro, and its name will be written as collectively 4-nitro-benzoic acid, benzoic acid. In this case, this OH group is acting as a branch, and it is at 4th position. So its name will be 4-hydroxy, and its name is benzoyl chloride. Benzoyl chloride. Its name is benzoyl chloride. If same type of substituents are there, I mean there is no special group over here, then the last named group is assigned position number 1. For example, in this case, there are 3 substituents. One is the nitro group, other one is chloro and iodo group. 3 main substituents are there over here on the benzene ring, and they all are, same type of substituents. So in this case, I'm going to write the alphabets. C for chloro, N for nitro, and I for iodo. So the last name group is nitro group, N for nitro. So its position will be number 1. According to this position, we will move clockwise, and it's a 2 position, it's 3, it's 4, and in this way we can get the lowest position for the branches. So chloro and iodo are acting as the branches. The name of this compound will be chloroiodo, 3-chloro dash 4 dash iodo, 3-chloro 4-iodo, and nitrobenzene. You can also mark the number over here if you want 1-nitrobenzene. 1-nitrobenzene. Now come toward the next example. In this case, it's a bromo, B for bromo, and it's a methyl group, M for methyl. So last name group is methyl in this case, so its carbon will be carbon number 1. It's carbon number 1, then the lowest number will be in this way, and you can write 2 over here, 3 and 4. So 2-bromo, those are the similar branches, and one is having 2 position and other one is having 4. So the name of this group will be can be written as 2, 4 dash di. 2, between numbers there is a comma, between number and the alphabet there must be hyphen or dash. 2,4 dibromo, 2,4 dibromo, and this rest of the molecule will be written in a single unit, or you can write as 1-methyl benzene. There are 3 different substituents. It's a methyl group, M for methyl. It's 1, 2, 3. It's a propyl. It's a methyl, it's propyl, and it's an ethyl. So alphabetically, the last name group is again methyl group. So this carbon will be carbon number 1, and we will start numbering in this way to get the lowest position for the branches. It will be 2, it will be 3, it will be 4. Now it's turn to write the name. The name will be written as alphabetically. E comes first, so I'm going to write over here the position of ethyl, 4-ethyl, then dash 2-propyl, then you can write simple methyl or 1-methyl benzene. That's all about the nomenclature as far as A2 chemistry students are concerned. I hope it's clear to you. Have a nice day.